In exams, you often find you'll get a question where you'll have to discuss the environmental impact or the sustainability values, I suppose, of a product, or you'll be offering up a product for them to discuss. And the main focus normally is on the general life cycle of the product, which normally involves raw materials, manufacture of the product, use and function, and the end of life or disposal of that product after it's finished its work in life. Products that I suggest you kind of talk about if you get the option are things like kettles, because obviously there's a lot of innovation in terms of being able to see water levels, advances in technology, auto off switches and things like this. Televisions, which have gone through a series of changes in terms of the way that they project the image, and obviously new LED or LCD televisions now are obviously saving a lot of electricity in that sense, and obviously the size of the products has reduced quite significantly, reducing the impact on materials and manufacture. Light bulbs is another common thing, again, that movement away from the standard incandescent bulbs, moving into sort of fluorescent and LED and electrodeless induction lamps that are used more oftenly nowadays has obviously saved a great deal of energy. And my personal favourite, if you get the chance to pick a topic to discuss, is obviously cars, because in terms of the car, we could talk about the efficiency of the product, we could talk about how the movement has gone away from perhaps petrol moving into biodiesel, electric, hybrid cars, the use of LEDs within the lights of the car to obviously reduce the impact on electricity and things like this, and several other benefits to do with fuel efficiency, aerodynamics and things like this that obviously have an impact. So if this question comes up in terms of talking about various different aspects, I recommend kettles, televisions, light bulbs and cars. Now, in terms of answer to this question, a useful acronym that I use if it doesn't give you criteria to discuss when you're talking about environmental impact is the acronym D.R.U.M, D.R.U.M, and this basically stands for D, disposal and end of life, R, raw materials, U for use and function, and M for manufacture and obviously distribution, which is obviously linked to manufacture. When you're answering these questions, regardless of the product, there are some key problems that come up and key things that can be done to reduce the impact. Now, if I start with disposal and end of life cycle, first of all, some problems that could come up is the fact the consumer could recycle the product irresponsibly or not know how to recycle the product. So an example of this might be a battery, for example, whereby signs should clearly be printed on the packaging and maybe on the battery that it doesn't go into the dustbin or the usual waste cycle and it needs to be taken back to a store. But a consumer could easily throw this in the normal waste disposal site without realising, or put it in the wrong sort of recycling bins, potentially contaminating a source. In addition to this, other sort of problems with products generally in terms of disposal is perhaps the use of polymers or plastics, as you might know them. Now, polymers obviously don't decompose particularly easily, so there's the aspect there that they'll be potentially sitting on landfill for many, many years. And perhaps even worse than polymers is if companies or manufacturers use composites quite a lot, which are quite difficult as well to recycle because they require splitting apart into the various elements. In addition to this, in terms of disposal and end of life, like with batteries, many other sort of products, things like fluorescent tubing and PCB or circuit boards contain toxic materials or metals inside them, which, if left to landfill or not disposed of in the correct way, would potentially be toxic to earth and water supplies and things. Now, in terms of reducing impact on these, the sort of things you should be thinking about, obviously, are trying to make designs timeless in their design as opposed to sort of moving with the sways of taste and fashion, so they will last a great deal of time. This links to sort of one of D.R.U.M's 10 principles of good design, which is a good design should last the test of time. In addition to this, manufacturers should be putting SPI codes or recycling symbols on products to make sure that the consumer knows how to recycle them effectively. We obviously want to try and reduce the use of composites as much as possible, or make designs so that they can be disassembled easily. So as opposed to using, for example, adhesives to adhere products together, using mechanical fixings or snap fits could easily make this better at the end of life or the disposal of the product. And obviously providing infrastructure on a sort of a council or a city-wide level to aid collection or disposal of this product would obviously help to reduce the impact at this point. In terms of raw materials, there is a series of problems as well. Now, one would be obviously the fact that many materials are finite. Okay, the likes of plastic is one such example, which is obviously derived from oil. And once the supply of oil is gone, the supply of plastic is gone, we've obviously run out. Now, in addition to the fact that the resources are actually running out, the extraction of these resources is often sometimes very costly to the planet and uses lots of energy, either during the actual extraction process or obviously the transportation of materials from place to place. So from the site of drilling, for example, shipping this oil to the various places for it to be processed. In addition to this, the effects of some processes such as mining, for example, in the case of aluminium, could also potentially have toxic effects and leave toxic waste on the site. Now, in order to reduce the impact of the use of raw materials, the manufacturer and designer could contribute to potentially minimizing the amount of materials used. So one such example of this would be for iPhone packaging that has moved away from the use of plastic vacuum formings and such to encase the item and keep it safe. And moved more towards the use of, for example, molded cardboard. Another such example is in sort of secondary and or tertiary packaging, whereas items used to be shipped in large expanded polystyrene foam blocks effectively, they're now moving away more to the use of air-filled bags, which again uses a great deal less material than in previous ways of doing this. In addition to minimising the amount of material, the percentage of recycled material can also be greatly increased, and this will obviously ensure that again we're limiting the need for these finite resources to be depleted, and the limit on the planet is a lot less. In addition to this, there's also the idea of reducing the amount of different materials being used, especially the use of composites I was saying before, which are very hard to separate, and obviously using potentially joining methods that allow the parts to be taken apart at end of life or disposal. And this obviously allows for materials which can later be recycled very easily. Now, in terms of use and function, there are obvious problems, mainly, I suppose, with products that have an ongoing power usage or energy draw. For example, as I've said in the particular examples, light bulbs, televisions, cars, where they are either using electricity or fossil fuels to power them. And obviously, some items are not as efficient as they could be. So, as I said, using incandescent light bulbs as opposed to more economical sources could be a problem. Now, in order to reduce the impact, as I said, we could use more efficient ways of achieving the same problem through products. So in the example of cars, for example, LED lights in place of standard incandescent bulbs, or the idea of replacing traditional fossil fuels such as petrol or diesel with an electronic source, perhaps responsibly sourced from a renewable energy supplier. In addition to this, the idea of insulation is another sort of aspect where we can improve the efficiency and lower the cost in terms of power and energy uses, both in our homes but also in refrigeration devices such as freezers and fridges, whereby increasing the insulation will ensure that the energy draw is much less. Now, finally, in the manufacture and distribution of goods, there are a series of problems. I've specified most of these before in things like raw material usage and stuff like this, but effectively the transportation of materials and obviously finished products from, for example, source to processing plant and processing plant to manufacturer to supplier, and even your sort of, as a consumer, your draw on transportation by going to and from the retailer. In addition to this, the manufacturer of the product is quite often going to use powered machinery in order to process the item, and there is additional problems linked with packaging as well, whether it is primary, secondary or tertiary packaging, for example. Now, reducing the impact on manufacture and in distribution, we can think about obviously the efficient manufacture of the product, so making products that can be made out of the fewest possible parts, reducing the use of adhesives, and this has a few benefits really. Obviously, one being the fact that it's easier to recycle at end of life, but also the potential sort of volatile organic compounds that are in many adhesives that pollute our planet and our air in that sense can also be reduced by not using glues and moving more to sort of mechanical fixings, snap fixing built into the molding process. In addition to this, the idea of tessellation and or nesting in manufacture. For example, If you are laser cutting an item, trying to reduce the amount of space in between parts to get the most out of every piece of material is one sense of this. But also in the distribution of goods, we're thinking about packaging items so that they can be easily transported from place to place, minimizing the amount of air in the shipment. So not shipping air and filling the entire space with goods and products as efficiently as possible is preferable in this sense. Again, talking about packaging, using sort of non-finite packaging materials, as I said, like molded card, and focusing more on sustainably sourced packaging materials, perhaps from FSC approved forest, could be beneficial, and reducing the amount of material used, whether through, as I said, air-filled polyethylene sacks, or where the secondary or tertiary packaging could be compostable. In addition to this, we can also use bio-batch additives in packaging films to achieve the same benefits.